They didn't build this temple. They revealed it. 400,000 tons of rock vanished from an Indian mountainside. Where did it go? The answer challenges everything we knew about ancient engineering. Picture this. 1200 years ago, workers began attacking a mountain from the top. Not from the bottom like every other construction project in human history. From the top. They carved downward through 200,000 tons of volcanic basalt, one chisel strike at a time, revealing a temple that would take modern engineers with dynamite and bulldozers an estimated century to replicate. But here's where it gets really interesting. The Rashtrakuta dynasty commissioned this project around 750 CE, and historical records suggest it was completed in just 18 years. That's removing 60,000 cubic meters of stone. That's filling 2,000 modern dump trucks. Every single year. For nearly 2 decades. And yet, when archaeologists surveyed the surrounding landscape, they found almost nothing. The rock had vanished. But that's not even the strangest part. The precision of what remained defied explanation entirely. To understand what makes Kailasa impossible, you need to understand what carving from solid rock actually means. When the Egyptians built the pyramids, they stacked blocks. Mistakes could be corrected. Damaged stones replaced. But at Kailasa, there was no room for error. Every single chisel strike was permanent. One miscalculation, one structural crack, and decades of work would be ruined, forever. And the evidence reveals something unexpected. The entire temple follows precise mathematical ratios found in ancient Sanskrit architectural texts called the Vastu Shastra. The proportions of the main shrine, the placement of every column, the angles of every carved elephant, all predetermined before the first chip of stone fell. If this is already shifting how you see ancient builders, drop a like so I know to keep going. Modern architects who've analyzed the structure found something remarkable. The margins of error in some sections measure less than 1 centimeter across spans of 30 meters. That's precision we struggle to achieve with laser-guided equipment. But here's the question nobody could answer for centuries. What archaeologists found next changed everything. In 2019, a team using ground-penetrating radar made a discovery that had been hiding in plain sight for 12 centuries. Beneath the temple floor, carved into the bedrock itself, lay an intricate network of drainage channels. Not simple gutters. A sophisticated hydraulic system designed to handle monsoon flooding that would otherwise have destroyed the structure within decades. Think about that for a second. These ancient engineers weren't just sculptors. They were hydrologists. They understood water flow patterns, erosion rates, and structural stress, concepts we teach in university engineering programs today. The channels were positioned to redirect thousands of gallons of rainwater away from load-bearing walls, through carved tunnels, and out release points positioned 50 meters from the temple base. But this discovery raised an even more troubling question. If they understood hydraulics this precisely, what else did they know that we've underestimated? The answer lay in tool marks that had been ignored for over a century. For decades, archaeologists assumed the Kailasa builders used simple iron chisels and copper picks, tools consistent with 8th century technology. But the real answer is even more impressive. In 2021, materials scientists analyzed the chisel marks using electron microscopy. What they found challenged assumptions about ancient Indian metallurgy. The tool marks showed characteristics consistent with high carbon steel, metal that supposedly wasn't developed in India until centuries later. The cutting angles were too precise, too consistent, to have been made with soft iron tools. Let me put this in perspective. High carbon steel holds an edge 10 times longer than pure iron. It doesn't deform under repeated impact. A workforce equipped with these tools could remove stone at rates previously thought impossible. Suddenly, the 18-year timeline started making sense. But this created a paradox that divided the archaeological community. If 8th century Indian metalworkers possessed steel technology this advanced, why did the knowledge seemingly vanish? The evidence pointed to something historians had overlooked for generations. But, everything I just told you? That's just the setup. The mystery deepens when we examine what archaeologists discovered about the missing rock itself. Remember those 400,000 tons of basalt that seemingly vanished? Researchers finally tracked it down, and the answer reveals the true genius of ancient Indian logistics. Geological surveys conducted between 2015 and 2022 identified matching basalt composition in structures up to 30 kilometers away. The rock wasn't dumped. It was recycled. The Rashtrakuta dynasty used the excavated material to build roads, irrigation channels, and smaller temples across their kingdom. They essentially created a circular economy 1200 years before the term existed. If you want to see how this reframes everything we think about ancient planning, make sure you're subscribed. But here's where it gets truly remarkable. The logistics required to move that much material, process it for secondary use, and distribute it across a kingdom, while simultaneously maintaining the precision carving at Kailasa, suggests organizational capabilities rivaling modern construction management. And we now know exactly how they coordinated it. And this is what they discovered. Inscriptions found at Ellora and nearby sites reveal a management system of staggering complexity. The Rashtrakuta administrators divided workers into specialized guilds, master carvers, rough excavators, stone transporters, and finishing artisans. Each guild operated under strict quality protocols enforced by royal inspectors. What nobody expected was the payment records. Workers were compensated based on precision metrics. Carvers who maintained tighter tolerances earned significantly more than those who didn't. This wasn't slave labor, it was incentivized expertise. Drop your prediction in the comments. Do you think this changes how we should view ancient construction? The inscriptions also revealed shift rotations designed to prevent fatigue-related errors. Workers carved during specific hours when lighting conditions through the excavation pit were optimal. They understood that tired eyes made permanent mistakes. But wait, there's one more clue that archaeologists almost missed entirely. And it explains the single greatest mystery of all. What the evidence actually shows is this. The temple wasn't carved as a single continuous project. Stratigraphic analysis of the excavation walls reveals distinct construction phases, each representing a different king's reign over approximately 150 years. The 18-year timeline in historical records? That referred only to the main shrine. The complete complex took nearly 2 centuries. But here's the revelation that changes everything. Each successive phase matched the previous work with such precision that generations of archaeologists assumed it was continuous construction. The Rashtrakutas had developed standardized measurement systems and detailed architectural plans that survived across royal successions, political upheavals, and even invasions. They created institutional knowledge that persisted for over a century. This is the true miracle of Kailasa. Not just the engineering, the knowledge preservation. They solved a problem that destroyed countless ancient civilizations: how to maintain complex projects across generations. The precision wasn't despite the time span. It was because of it. Multiple generations of master craftsmen refined techniques, improved tools, and corrected predecessors' minor deviations. And this brings us to the question that matters most. Why did this knowledge eventually disappear? The answer is sobering. When the Delhi Sultanate conquered the Deccan region in the 14th century, the patronage system that sustained these specialized guilds collapsed. Without royal support, the master craftsmen couldn't train apprentices. Within 2 generations, the techniques were gone. Not lost to time, lost to political disruption. The Kailasa temple stands today as both monument and warning. It proves ancient humans were capable of organizational genius, metallurgical innovation, and precision engineering that rivals modern capabilities. But it also proves how fragile knowledge systems truly are. We like to imagine progress as inevitable, as cumulative. Kailasa reminds us it isn't. Now you understand why 400,000 tons of rock vanished without a trace, and why we almost lost the knowledge of how it happened. The real miracle wasn't carved in stone. It was written in systems, passed through generations, and ultimately forgotten when the institutions that preserved it fell. Think about what we've uncovered together. An ancient civilization that understood hydraulic engineering sophisticated enough to protect a structure for 12 centuries. Metallurgists who developed high-carbon steel tools centuries ahead of conventional timelines. Administrators who created quality control systems and incentive structures that would impress modern management consultants. And most remarkably, knowledge preservation techniques that maintain precision across 150 years of continuous construction. The Kailasa temple isn't evidence of lost super technology or impossible capabilities. It's evidence of something far more impressive: human organizational genius operating at the edge of what was physically achievable. They didn't have secret knowledge we've lost. They had dedication, systems, and institutional memory we've chosen to forget was possible. Every chisel mark in that mountain is a reminder that our ancestors were exactly as intelligent, creative, and capable as we are today. They simply applied those capabilities differently. But Kailasa raises one final question that scientists are only beginning to explore. Across India, dozens of similar rock-cut temples exist, each with its own engineering mysteries. The Ajanta caves feature acoustic chambers that amplify chanting to specific frequencies. The Undavai caves contain multi-story structures carved from single rock faces. The Varaha cave temples show evidence of standardized measurement systems that span 500 years. What connects these sites? Were they built by the same guild networks? Did knowledge transfer between regions, or did multiple civilizations independently develop similar techniques? These questions drive ongoing research that could rewrite our understanding of ancient Indian engineering networks. Subscribe to Decode More Lost Knowledge, because every mystery we solve reveals ancient genius, not impossible technology. What ancient achievement impresses you most? Or do you still have doubts about what they could accomplish? Let me know in the comments. Now you know the truth behind the vanishing mountain. 400,000 tons of rock transformed into roads, temples, and irrigation channels across a kingdom. Advanced steel tools that cut through basalt with precision we struggle to match. And institutional knowledge systems that maintained accuracy across 150 years of construction. The Kailasa temple isn't a mystery anymore, it's a testament to what humans can achieve when organization matches ambition.